Welcome to this nonlinear static and transient analysis demonstration using Autodesk Nastran In-CAD in Inventor. Autodesk Nastran In-CAD can handle three major types of nonlinearities. These are nonlinear materials, nonlinear boundary conditions, and nonlinear large displacements as a result of large deformation. During this video, we're going to illustrate how to run a nonlinear analysis using the simple pole model. In order to set this pole model up for a nonlinear analysis, we will create one subcase here where we will apply a downward load to the pole. We will follow that load with the second case where we will remove the load. What we're looking for when we run this analysis is how much the pole will bend as a result of the downward load. Our load is high enough that we will be well into the plastic region of the material, and the pole will remain bent after the load is removed. When we create our material, in addition to the regular linear properties, we choose the nonlinear button. We will choose a bilinear material where we will put in an initial yield point and a tangent modulus that represents the reduced stiffness after the material yields. With our load already applied and a nonlinear static analysis chosen, we are ready to run the model. After running the analysis, we get a deformation on the order of 7.25 inches. When we remove the load, we can see the pole is still bent, about 1.7 inches as a result of the material plasticity, with a stress of about 20,000 psi. The other type of nonlinear analysis that can be run is a transient analysis. We will illustrate this with the same pole model. In this case, we will use an enforced acceleration to see how the pole behaves dynamically. To define a transient loading, we'll use the table function down here. We will define a function that starts at 0, goes up to a value of 1, then down to 0 again. We can see that it has a fairly sharp initial acceleration that falls off more gradually to 0 at about 50 milliseconds. We can then run the analysis. A transient produces a lot of output. We'll just look at one point. After about 40 milliseconds, the initial shock has passed, but the pole is still responding dynamically. On this stress plot, you can see that unlike the static analysis, the highest stresses are in the center of the pole. They are over yield, so the pole can be expected to acquire a permanent bend. Another result that's worth looking at from a nonlinear analysis is the plastic strain plot. The strain plot will tell you exactly where you've exceeded the yield point and how much the part has bent. Although nonlinear analysis comes at a cost of increased runtime and complexity, Autodesk Nastran In-CAD's nonlinear static and transient analyses offer engineers a greater ability to examine parts compared to using a more simple linear analysis.